Okay, greetings. Let me turn off my thing there. Just laugh. I've decided to just go ahead and redo all these videos to make it up to date. So this is the actual date. Now we're going to look at Freefall. Okay, we're going to drop object. We're going to drop two objects. So let me take something that's kind of heavy, which is this, tape dispenser, and take something kind of light, which is this thing, and let me show it over here on this desk. Oh yeah, I'm trying to make it look like I'm really Mr. Physics by reading my Einstein book. Now watch what happens. When I drop these two objects, I'm going to drop them from about the same height. I don't know if you'll be able to see me standing over here. My head is cut off, but I'm going to drop these two objects from the same height. Let's just clear this out a little bit. And get them right at the same height. Let's see which one hits it. This one's much lighter than this one. Let's see which one hits the ground first. Hits the table first. They hit at the exact same time, right? They hit at and that's because one, we didn't. There's two reasons for that. One is when we're here, if we drop them out in deep dark space, they would have just floated. There was no gravity. Okay, there's no gravitational field pulling them down, accelerating them towards the center of the Earth, so they just float. But here on Earth, because they're both being pulled at they're both having the same force, the same acceleration, pull them down. Not the same force, the same acceleration, pull them down. They fall at exactly the same rate. And in this lab, what you're going to do is you're going to hold a ruler, maybe a meter stick like this, or actually, this ruler might be too small, but if you hold a regular ruler like this, and then you get it started, and you measure, and we're going to measure the reaction time. In other words, how long does it take before you drop it that the person that's going to catch it, how far it falls. So just doing it myself, which is stupid. You can't do this yourself. You have to have a partner. In other words, you're going to have like 15 people or 10. Let's say 10 people that host 20 people. Jesus, sorry about that. Get 30 people. Find 30 people. All right. That's why this lab takes a minute, because you're going to have to find 30 people. And you can come to our labs here. The schedule of our labs, I will post those. And I'll let our lab instructors know that you guys might be coming through and kind of bothering people and saying, you want to test two groups, either male and female, or have people do it with their right hand. If you can only find 15 people, have them drop the stick with their right hand or catch it with their right hand, because you're going to drop it. In other words, you'll say, ready, you're going to have it here. You're going to say, ready, set, go. And see how, and then measure how far the stick fell, ready. Since I know it, so that one went almost 10 centimeters. Okay. That one was almost 10 centimeters. But that's just doing it myself. So one thing you can do is you can test right-handed versus left-handed. If you can find 15 men, 15 women, you're going to test and see what their reaction time is between those two, and you're going to run a statistical analysis. That's essentially what the experiment is. Now, so that's what the experiment is, but what is acceleration? Acceleration is the change in speed over the change in time. And the Earth pulls down on an object at 9.8. All right, so if you start off going at a velocity of, and I'll write this out for you. I'll embed it. As a matter of fact, let's embed that now, because I've got my ladybug on. So here we go. Here's what we're talking about. In other words, when I'm talking about 9.8 meters per second, this is what I mean. For every 9.8 meters, so the acceleration due to gravity is 9.8 meters per second squared. In other words, your speed that you're falling, your first second, 9.8 meters per second. T equals 1, this is how fast you're going. This would be your velocity. At t equals 2, be 19.6 meters per second, because it's the acceleration times the time gives us the velocity, okay, at different times. So this is your velocity after 2 seconds. This is velocity after 1 second. Your speed after 3 seconds would be 9.8 times 3. Luckily I got my calculator right here at 9.8 times 3, which is equal to 29.4 meters per second. This is equal to V3. Okay, well that's pretty big. I mean that's really fast. In miles per hour, that meters 20 in my physics and sport class where we do this calculation. But I'm going to just do it real quick. You're going almost 66 miles per hour. So after you fall, if you free fall from somewhere, you'd have to be really, really high because you're going to cover a lot of distance in that time. 66 miles per hour. So there's your introduction to what acceleration is. All right, it's the change. Acceleration is the change in speed or velocity. We'll say speed for our class. Speed divided by the change in time. That's what acceleration is. All right.